Assalamualaikum warahmatullahi wabarakatuh. Today, we would like to present you our mini project for ECA 431. The title that we have been received is Water Quality Analyzer. Before we are going to the mini project, I would like to introduce my team member first. First, Haris Akmal bin Azizan. Second one is Muhammad Adam Shafi bin Muhammad Amir. Lastly is me myself, Muhammad Himan bin Shoaib. Okay, this is the topic that will be covered in this presentation. First is the introduction. Second is the methodology part. The third one is flowchart. The fourth one is the demonstration. And lastly is the conclusion. Okay, the introduction. We have four main parts here. First, I would like to introduce the water quality analyzer. The water quality analyzer is a device that will monitor and measure the quality safety uh, at the specific place. So for this mini project, we would like to monitor four main key parts, which is pH level, turbidity, dissolved oxygen, and lastly is temperature. So we are receiving the dataset is from Kaggle. It's an open source website that we can obtain such data. So from the CSV file itself, the data is obtained from Brisbane River, which is at Australia. So all the quality or the observation is from there. Okay, the third one is the clean water and sanitation SDG 6. SDG is the sustainable development goals that is been introduced by the United Nations of members, which encourage all the countries and all together to sustain the earth with a correct way and also follow the guidelines. So the first of the goals that will be covered in this topic is the clean water and sanitation, which the SDG 6 will address the water related issues. So the lastly is the water regulatory standards, which is we have WHO and Jabatan Alam Sekitar Malaysia JAS, which is the local regulatory. So these are the safety measures that we need to cater in order to verify our finds. So now I'm going to pass it to Adam Shafi to continue the methodology part.
For methodology, we have 17 to discuss. For the first one, we have data collection. Data collection that we obtain is from Kaggle, or we manually input into the program itself. So the data that we need to be input into the program is pH level, turbidity, dissolved oxygen, and temperature. So first, secondly, we have data processing. Data processing, we imported the dataset using relevant programming tools, ensuring proper formatting and removal of any inconsistencies or missing values. Third one, we have analysis implementation. So it was programmed predefined threshold for each water quality parameters based on what WHO or local standards for drinking water. In this case, we have JAS, which is Jabatan Alam Sekitar. So for the fourth thing, we have output generation. A design report summarizing water quality based on the analysis, which categorize water as safe or unsafe. So number 5, we have customization. We enable customization by allowing users to select analysis and standards. By standards, I mean we standards regularity, which is WHO or JAS. For the 6, implementation and testing. So we developed and integrated the project code and then tested the program using diverse dataset to ensure accuracy and robustness in detecting unsafe water quality levels. Next, lastly, we have documentation. We compiled detailed documentation outlining in the input structure, analysis methods, and interpretation of results. So let's move forward to flowchart. Now we have flowchart here. So at the top we see a start, and then it will move on to display menu. When the display menu move forward, we'll encounter a choose an option block which will appear to show enter manually or import a data set CSV file or quit. So if we input enter manually, we will enter the parameter manually by ourselves. We can see that on the left side, we need to enter pH value, turbidity, dissolved oxygen, and temperature. And after registering uh, 4 of that data, we will go to another option block which asks to calculate the data and decide in which standard regulatory. In this case, we have GAS and WHO. After choosing one either of those, it will display the parameter of the water and the condition of the water, and then it will go to another block, option block, to determine is the water safe. If the water safe, it will display safe to consume. But if the water is unsafe, it will display a recommendation to improve water conditions. So let's move on to back to choose menu option. If you choose CSV file, import a dataset from CSV file, it will ask you to choose the name of the file that you want to import, and then when you choose when you register the file, all of the ID of the date of you the chosen date you want will appear, and you simply register the ID of the date. And we'll go to the same process, which selecting the regulatory standard. But this different the difference between this one and the manual one. The manual one displayed all of the condition first, right off the bat, and then but this one need to display the data of all of that day from for the whole day or for 24 hours. So it will display the same thing, and then determine the water. But the only difference here is it will ask you again if you want to analyze another date, which is not it's not available to the manually input. So if you choose to analyze another date, it will go to ID again, and simply enter ID to analyze another date. So if you do not want to that, you can press no, register no, and then it will go back to the display menu. And then the other option to display menu and choose option, and you just simply can quit the program. That's it. Next, I will move on to Haris.
Okay, thank you, Adam. I will continue for the demonstration. So for the demonstration, here is the code running. So here you can see is our main menu, which is water quality analysis menu. So here we have 3 options that user can choose. This first is enter data manually. Second is analyze data from CSV file. And the third one is quit. So let's, first of all, let's try the first option. So the first option, the user will given enter pH option, which is 1 to 10. if the user, for example, exceed the threshold that the data wanted, so the data will get to invalid pH value, and it will return back to the option. So for example, that day the pH is 7 and the turbidity is let's say it's 3. The oxygen I will say 4. Temperature 30. So what happen is next the data there will be another menu for the user to choose the JAS or Jabatan Alam Sekitar Malaysia Regulatory Standard or WHO World Health Organization Standard. So the difference of this data is the pH value. For example, the user choose number 2, this WHO standard regulation. So the program will execute what a user entered before and determine whether the condition is safe, moderately safe, or unsafe for that day. Then the program will execute the parameter or the list of the unsafe parameter, moderately safe parameter, and determine what the user can make to improve the safety of the water. For example, here the dissolved oxygen, which is here is unsafe. So user can increase the dissolved oxygen by aerated the water using mechanical aerator or increase water movement. So here in moderately safe, also the turbidity, which is moderately safe. And the improvement that the user can use is to use final filtration or fluctuation method to reduce suspended particle. So overall water safety is unsafe to consume because what the program is used here is if there is one unsafe condition, the total of overall safety of the water is unsafe to consume. So next, the program will continue to go back to the main menu. So next, we will analyze for the CSV file. So if the user choose to CSV file, then user can choose which file that user can enter. For example, here we got the Brisbane water quality CSV file. Okay, so that's it. Then you can see that the program will give the user all of the date in the file. For example, here we have around 289 date in that file. For example, user choose file number 1. So again, the user need to choose the regulatory standard for either JAS or WHO. For example, here user choose the JAS. So the condition is overall is safe. If the condition is safe, there will be nothing needed to improve the water. If we choose back 1 and we choose the WHO, so the water will pH will change to moderately safe, and here we can see how many times that the pH is condition the pH is moderately safe, which is in this case is two times in a day. So the condition we use here is if there is more than 5 times moderately safe in that day, the water is we assume that the water is moderately safe to consume. Another example I give, if for example 26 standard, what happened is there is a 77 times turbidity, unsafe parameter turbidity in that day, which is the program will execute is as unsafe to consume. So next, as you can see, the user need to have either to continue to choose another date or go back to the main menu. The user choose to go back to the main menu. Again, the main menu, user can choose 3 parameter. So if user want to quit, just start queue and the program will ended. Right. Thank you. So I will continue to my friend Hilman for the conclusion.
Yeah, that's all for the demonstration part. Now we've come to the end of our presentation. As from my fellow friends have been present, it can be said that the water quality analyzer project has been successfully running. Also, the coding is running without any error. So it is verified that the mini project of this programming is approved and can be used in the future for any problem solving related to the water, addressing any water issues. So that's all from us. Thank you very much.